Hello everyone, welcome back to LeetCode Daily Live where I do the daily question, raw and uncut. So we have a HUD today called maximum candies you can get from boxes. So let's see what the question wants. It does look like it has a lot of variables. So we're given n boxes, and what is n? So n is actually only 1,000, and right, so everything else is like around 1,000 maximum as well. So you have n boxes, 0 to n minus 1. You're given 4 arrays. So we have 4 arrays. Status I is 1 if the ith box is open, and 0 if it is closed. So status would be like a Boolean value basically. Candies I is the number of candies in the ith box. Keys is a list of the labels of the boxes you can open after opening the ith box. A list of the labels. But what are these labels? Alright, let's just keep going. Contained boxes I is a list of the boxes you found inside the ith box. So you have boxes within box. You're given an integer array initial boxes that contains the labels of the boxes you initially have. You can take all the candies in any open box, and you can use the keys in it to open new boxes, and you also can use the boxes you find in it. Okay, I don't understand the question at all, so let's look at the example. And we want to find the maximum number of candies you can get using the rules. Okay, so status, so that will be open and closed. That will be a number of candies in each box, I think, right? Yeah. And then you have keys. So the third key contains 1, and then contained boxes. So you have like 1, 2, and 3. So and then initial boxes is like 0. So you'll be initially given box 0. You'll find 7 candies in it, and boxes 1 and 2. Wait, does that mean 0 contains box 1 and 2? So box 1 is closed, and you do not have a key for it. So you open box 2. Yeah, okay, so that's closed. How do we know we don't have a key for it? Is it because like box 2 has key 1? Okay. So yeah, okay, so you open box 2. You find 4 candies and a key to box 1 in box 2. Right, so I think what keys mean is like what keys are in that box, right? Yeah, okay. So yeah, after you open the ith box, you get all the keys in that list. And also after opening the ith box, you get access to all the boxes within the ith box. So like you can have box within boxes, and like you can have a box within a box within a box, and so on. Right, so you open box 2, you'll find 4 candies. So that would be this. And you also find a key to box 1 in box 2. So that means like you can open box 1. So in box 1, you'll find 5 candies. In box 3, but you don't have a key for box 3. So box 3 is going to remain closed. So the total number of candies collected is just this. Okay, let's just look at example 2 as well, so we know what was like really going on. So initial boxes, we have 0. So you have initially you have box 0. Opening it, yeah, so you can find all the other 5 keys to open that. And then you also have 1 to 5, like, so basically all the boxes are within box 0, and you'll be able to open all of them. And yeah, so that means you'll be able to get all the candies. Yeah. So looking at this question, my first idea is definitely a BFS. So, and because the bound is actually quite small, what we can do is that we can basically, for each depth, we can just loop through and see if there are any available boxes at the moment. And we put it in our queue. We get all the candies and we open all of those boxes. We get all the keys. So when we get a key, like basically we just update the status. And when we um and yeah, and when we open like some boxes, we also have to check which box are actually available for us to open. And like with all these checks, we'll be able to, well, basically get all the available boxes to open. And like if we also use like scene sets, uh we can make sure we don't look at already opened boxes. So that would mean that basically every depth you only look at 1,000 boxes, and well, our depth is at most 1,000, so it will be an n square time complexity kind of solution, and it should just work. So yeah, I'm not sure why the bound is so small. I feel like it is still possible to do this, maybe in like n or n log n, but well, if they're asking for an n square algorithm, you should never really hesitate to just write an n square algorithm. So yeah, I'm going to start coding now. So the first thing we need is we need a queue for sure. So our queue is just going to be the initial boxes. So B for B in initial boxes. Right. And then so down here we're gonna have a loop, right? And we're gonna have a new queue, so that will store all the, well, all the new stuff we have. Actually, do we even need that? Maybe we don't. Maybe we can just set queue. Wait, get available boxes here. So like we can do something down here, and then at the end we can just return. Is it like candies? Oh wait, that's the array. So I don't know. Let's just call it like total candy at the end. So what does that mean we need up here? So we need total candy. Initially it will be 0. We also need a scene set. So that means like we have seen those boxes already and we don't want to look at it again. And then we also want to get like available boxes. So that'll be the boxes that that we actually have access to. So like from the contained box. We can make that a set as well, I think. Yeah. Do we need anything else? So keys. So I think like when we get the key, we just like the only thing we have to do is we just have to update our status array. So we don't even need a new another data structure for that. So we have a queue initially. We want to. Oh yeah, what happens if the initial box? Well, yeah, what happens if we don't have a key for the initial box? What do we actually do in that case? Um, that's a good question. I think if you don't have the key, you can't open it, right? I think. Um, okay, how do we want to do this actually? Um, I feel like, yeah, there are just so many ways to do this. I'm trying to think of the best option. So initial boxes, maybe for the queue up here, we add our unopened box in, like so if the box is closed, we would just add it to available boxes. So we can like check against it afterwards, right? Yeah, so I guess another way to do it, that way is a bit dumber. I'm thinking of like having a key set. So basically like all the opened stuff would be, well, actually that could be cleaner. So keys would be a set. But then we turn all the boxes. So I for I in range, length of status. We should also get the size of n here first. Just makes things a bit easier. So range n, if status I is equal to 1, I think that will be open, right? Yeah, if it is equal to 1, it will be opened. And then we can also just put all the available boxes into here. So available boxes. Yeah, so we can put all the initial box here. So B4 B in initial boxes. And then our queue is going to be B for B in available boxes. If if keys B oh wait, if B in keys, yeah. So if B in keys, so that means like we have the key for that, right? So we can just do that, and then so while queue, so now we are guaranteed that all the boxes we open, like we can actually open them, right? So so we can do while queue again. We can just loop through queue, honestly. So we just do for how do we want to do this? Yeah, so I guess like for box in queue, we can get all the contained boxes first. So yeah, also is it possible that, yeah, okay, all values of keys I are unique, which makes sense because you can only have one key, I think. Oh wait, no, you can have more than one key, but I'm just trying to see. Yeah, each box is contained in one box at most, so we won't have any recursive problem. Yeah, okay, that actually makes things a lot easier. Yeah, because like that means we'll only be opening we'll only be adding each box into available boxes once. Okay, so for child in we'll just call it C. I think in contained boxes B. So that's how we get all the boxes here. So if C not, so if I don't think we even need that, because like when we see a new box here, we know that we haven't seen it before because each box could only be inside one another box. Okay, so we want to add that to available boxes. Add C. And then we also want to add all the keys it has. So for key in, so for key in keys B, yeah. So keys dot add. So we want to add it to this set. We want to know that like we can open it now. So we want to add K in there. I think that's all we have to do. Oh, we also have to actually get the candy out, I think. Yeah, so what we can do is total candy candies B. And we also should put B into scene set, because now we are done with that, right? We don't want to like add that again into the queue. So let's see. Queue. Yeah, I guess like the most primitive way of doing this is just looping through all the available boxes. So for box in available boxes, so if we haven't seen that box before, so we haven't like opened it before, and being keys, so we do have like, so we can open it, then we want to add it into our queue, right? So queue.append B, and then at the end, yeah, that there's no at the end, because like we'll have set queue to be that. And yeah, I think that should just work, I think. Well, unless I'm missing something. It's not defined, contained. Oh, whoops. Set is not subscriptable. Wait, really? Oh, like, it should be. Wait, what? So keys should be. Oh, I duplicated it. That's not good. I should call this like available keys, maybe. So yeah, so now here, so that one should be available keys, and this one, yeah, keys B. So this one should also be available keys. In available keys, what about now? I hope I didn't mess up the key stuff. And okay, nice. Yeah, this question is, I don't think it's too hard. It's mostly like it has a lot of data structure. I think like this question, like the difficulty of this question comes from the fact that it has a lot of data structures and like a lot of information you have to keep track of. But like if you look at the code, it's just a simple BFS. So yeah, I guess I can talk a bit about how I thought about this solution. Well, so when you open a box, so when you open a box, you get access to some other box, right? So if you think about it as a graph, so if I draw this out, it's a bit small. I'll try to draw bigger. Which one should we draw? So let's look at example 1, right? So initially we have box 0, and box 0 contains box 1 and 2, right? So it contains 1 and 2, and then box 1 contains box 3. So if you draw it out as, like, if you think about it as a graph, it makes a lot of sense that you want to do this in a BFS. But what is the other condition we have? Is whether the box is actually opened and whether we have a key, right? So we have like two states that determines whether we can actually open a box or not. So before we can actually go into like, let's say like box 1 and box 2, well, we have to make sure that the box is either opened. So for example, like for the status for 2, it is opened already, right? So that means we don't need a key to open it. Or if the box is closed, do we have the key to open it? Well, so for the initial step here, like when we just open 0 and have access to 1 and 2, well, box 1 is closed, and the key for 1 is like for the key for box 1 is in box 2, right? So that means like we don't have the key and the box is closed. So that means like we actually don't have access to this. So we have to like somehow pause this DFS until we get the key for it, right? So if that's the case, well, what can we do? Like we can just use a set to keep track of all the boxes that we can that we have so far, but we just don't know whether we can open them yet. So that means like when we look at the next step and look at all the children, well, if we somehow get the key like here, or maybe it has like more children, right? So if key 1 is in here, eventually it'll get down to like box 5, and then you can like open this up again. But I guess like yeah, so that's kind of like the idea of this whole question. And another thing to notice is that if you look at the code, I have while queue is not empty, right? So if the queue is empty, we would just skip straight to like this part. So what does that mean? That means for every iteration, we are opening at least one box, and we only have 1,000 boxes. And also every time, like for here, we're just looping through at most 1,000 boxes. So that means like we are, well, we have like 1,000,000 operations at most, and like that's why n squared works, right? So I guess like having to like think about the like the time complexity as well, like just really helps out with the question. So yeah, I think this question is mostly just like implementation and like simulating what happens. So yeah, there are not too much to really explain other than that. But yeah, if you have any comments, or if you want me to do anything like with my content, make sure to comment below to let me know, and I appreciate all the feedback. And yeah, thanks for watching, and I'll see you tomorrow. Bye.